Mrs. Beck. My lords, my lady, there are a couple of further points I wanted to just flag up to try and keep an eye on at this stage before I turn to the detail of the invention. First one is this. We've been talking about principle of general application, and a patentee's technical contribution may, as I've explained, be a principle of general application. And of course, it can vary from case to case. It could be a technical effect that one achieves in all the products that have the combination of features identified in the claim. The structure with the fixed-winged shaped to provide the uplift that I mentioned earlier. Or to give you another example, hopefully without overcomplicating it, you remember the old-fashioned televisions? Cathode ray gun behind a phosphorus-coated screen with electromagnetic coils to control where the electron went on the screen. So it could be the technical effect that you achieve from that combination of features. But in other cases, for instance, where particular products are already known or obvious goals, the technical contribution may lie in a particular generally applicable method enabling a particular class of products to be made. And a point that I think I've already foreshadowed this morning, but it's an important point, the former case are cases where the principle is embodied in the combination of the physical features of the product. It's that you have a product with these features and that enables you to achieve the particular technical effect. And just to pick up on a point that my Lord Briggs made this morning, you don't normally write the technical effect in the claim in addition. But in fact, here in this claim, in our case, we do have some wording or requirement in the claim which is directed to what it does. And it's something which maybe has been overlooked a little bit. I just wanted to draw attention to it. So it's MS 416, claim 1 of 163. The claim obviously has all the words that require what we've been using as shorthand, the reverse chimeric locus. But look at the first line. A transgenic mouse that produces hybrid antibodies containing human variable and mouse constant regions. So there is part of, in the claim, what it does. And in fact, when I explain the invention to you, you will understand that it's the production of that which cures the sickness. Now,
it cures the sickness.
Yeah, it
is murine sickness.
The immunological sickness
of the mouse.
And the primate mouse.
Cures or avoids?
Avoids, actually. Avoids is a better word. You're absolutely right. Avoids.
It's because it has a normal immunological response that it's able to produce the antibodies that are the desired end product.
It's what happens to the antibody or the B cells after their initial production that's crucial. I'm going to come on and explain it to you, but it's the fact that the antibodies are hybrid that avoids the sickness.
And just be clear, what do you say the invention is?
The invention, my learned friend is right that it's that which is in the claim, but the essence of it, the technical contribution, is providing a mouse with this reverse chimeric locus, producing hybrid antibodies, which, because of that, so this is the technical effect, avoids the sickness.
It's not the ones they produce, is it? Is it the ones they produce that avoid the sickness, or is it because they avoid the sickness that they produce them effectively and rapidly and fast?
No, it's because they're producing those. I will.
It's a chicken and egg issue there, which I'm not sure I've got to the bottom of.
Yeah, you will understand in about an hour's time.
I might.
No, you definitely will. Now,
But the invention isn't the process of producing the mouse. The invention is the mouse.
it is the mouse.
In claim 1, there are method claims in
Yes.
2 and 3 of EP 163.
Yeah, but claim 1, the one we're fighting about, it is the mouse. And it's the mouse with that physical characteristic, the reverse chimeric locus, because that is, we can't look at it, but we know it's there. And I'll explain how it does the trick shortly. Now, the reason I'm rather labouring this point about the distinction between a case where the principle of general application is embodied in the product, or cases where it's not embodied in a product, it's just something that enables a class of products to be made, is because of the way my learned friend seeks to address the question of principles of general application. Can I ask you, please, to take his case and look at para 144, which is on MS 105. Here there's a quote from Lord Hoffman in Biogen, simply giving an example of how a patent may be insufficient. And Biogen was a case where the hepatitis B antigens were known or obvious goals. And so the technical problem was how to make them. And so what Lord Hoffman says is perfectly straightforward in that context. But the conclusion my friend seeks to draw from this at the start of para 145 is where he slips the ball between your legs. What he says is that a principle of general application that doesn't enable products to be made cannot assist, not ever, as I understand the way he elaborated the point yesterday. Now, that submission is absolutely fundamental to my friend's case, and it's simply wrong in my submission, as put forward as a rule applicable in all cases, regardless of the nature of the invention and the technical contribution. As I understood my friend's submission yesterday, I think he accepted that a mouse with a reverse chimeric locus is a principle of general application. I think he even accepted that it was the principle of claim 1 of 163. And I didn't detect that he quarrelled with the fact that such a product would have the technical effect of the mouse making hybrid antibodies and not therefore suffering from the sickness of the prior art mice. His case is simply this. You ignore principles of general application that are embodied in new and novel products. He says they're irrelevant. Any principle of general application is irrelevant unless they go to the enablement of manufacture of the products. Now we say what is required as an enabling disclosure depends crucially on the nature of the technical contribution, the nature of the invention, if you will. And where the inventor's contribution is not in enabling known or obviously desirable products to be made, but where, as here, the inventor has actually devised a new inventive product. So what's happened here, Dr. Yankopoulos has devised a new inventive product. The principle may lay in the new inventive combination of features that that product embodies, which give a new technical effect. All products with the inventor's new combination of features are themselves new in their combination of features, necessarily, and they achieve the same inventive technical effect. And where the technical effect would be understood to be achieved in all products made with the particular combination of features, the principle of general application may lay there. It need not be principles that are directed to enable each of the products covered by the claim to be manufactured. As I keep saying, the issue is highly sensitive to the nature of the invention. And I would add this. In a real sense, by disclosing a principle of general application, the inventor does enable the invention to be performed across its full width. Performing the invention requires the provision of the particular novel and inventive combination of features. And it's not really to the point to say that particular products that enable the invention, that embody the invention, cannot be made for some other reason. For instance, the unavailability of Frank Whittle's jet engine in the Wright brothers case. The invention can be performed by reason of the disclosure of a principle of general application. And I go further. My submission is that the area over which the invention can be performed is the area which the principle is and would be understood by the disclosure to be generally applicable. So it's puzzled.
Yeah, well, it's just, I'm just frowning at the use of language. The invention is probably the mouse, but you're saying it's a technical contribution, which one might say is embodied in the mouse.
Yeah.
Right.
And the area over which you can perform that is the area in which the principle is and would be understood by the disclosure to be generally applicable. And you'll understand shortly why the number of inserts, number of V inserts, is irrelevant to that. And can I illustrate this briefly by returning to the television example I gave you? The first most basic television was monochrome, limited by the speed and accuracy of the electron gun, so you had a flickery picture with low resolution. Perhaps not very many pixels. Let's assume it was 50 by 50. But the basic invention is not dependent upon the quality of the electron gun or the precision of the accuracy that you can achieve by the electromagnetic coils pointing it at particular points. Embodiments with faster and more finely controlled guns would give greater resolution and were clearly desirable but not immediately attainable. Likewise, improved phosphor on the screens. When you enable separate red, green and blue emitting phosphor screens, you can have 3 electron guns and start composing a colour picture, not enabled by the initial disclosure of the flickery old black and white one, but all of them are ways of implementing the original invention because that technical contribution is embodied in the product. And the difference between the parties is Mr. Purvis says the principle of general application, if it does nothing to enable the making of the products, is irrelevant. So he says the inventor of the TV must limit his claim to that which could actually have been made, the grainy, flickery monochrome device. And he says those that follow with improvements, the improved, faster, more accurate electron gun, giving higher resolution, get to use the inventor's contribution for free. And that actually is the substance of the passage in the transcript that my learned friend showed you in the Court of Appeal. That's what Lord Justice Floyd and Lord Justice Kitchen were, the point they were drawing attention to. And our case is to the contrary. We say principle of general application relevant for sufficiency may be, not always is, but may be something embodied in the product. If it's a new and inventive combination of physical features that gives a technical effect, that can be the principle of general application relevant for sufficiency. And the final point, before I give you the headlines on the invention and the cases, that I would add is this. When we speak about tolerating occasional failures, something that my learned friend referred to, in this context, what we're really talking about is the possibility of there being occasional instances where, once made, the product doesn't have this common technical effect. And once made, it doesn't have it. So it goes to the question of whether there really is a unifying principle of general application at all. Not that you have to be able to make everything on day one. Now, can I just give you some headline summaries of what we're going to see when I look at the invention, and also what we see in terms of what was in issue in some of the cases that my learned friend Lord Panics asked me to cover. First of all, the invention. As you know, it's a product claim. It's in fact live products. It can be used as a platform or a tool for a crucial step in development of many, many therapies using antibodies. And I shall come on to elaborate the point, but the headline is, these mice are used to provide their immune system to do the work necessary to develop a cell containing DNA that codes for a specific humanized antibody. The headline is, we are using their immune system to do the work necessary. And the magic is the reverse chimeric locus, enabling hybrid antibodies to be made. And as I've already said, that's a physical feature of every mouse in the claim. It has nothing to do, not just the claim has nothing to do, but when you understand the technical contribution that I'll explain, it has nothing to do with the variety in the starting material that you feed in to the immune system. It's all about providing an immune system which actually works efficiently. My learned friend's point is actually all about increased diversity in the starting material fed through the immune system.
Can I be clear what you mean by that? Do you mean the genes inserted into it or the antigens presented?
I mean the genes, not the antigens. It's to do with what you start off with when what they're called naive B cells go off into the body. So his point is all about the variety in the combination of variable regions that might be in a B cell. And that's what you feed in to the immune system. It's nothing to do with whether the immune system is working efficiently. And you will understand that very shortly. And you can see that they're focusing on something different if we look at their case. We look at para 122 of their case. So I'm now looking at the passage bridging MS 98 and 99. starts at the bottom of 98. They assert the effect of the Kymab, that's the infringement with all the V regions inserted, is different. They say it's much improved. But then what follows at the top of MS99 is crucial. In terms of combinational diversity, in fact, they focus only on one way in which diversity is contributed to, ignoring others. But the headline point at this stage is they are simply wrong to say the effect of the reverse chimeric locus in the Kymab is different. The effect of the reverse chimeric locus is not different in the Kymab. It's precisely the same, avoiding the immunologically sick mice. And in fact, you can actually see the point easily by pausing and thinking about the mice that were conventional prior to Dr. Yankopoulos' invention. Mr. Purvis explained yesterday they incorporated the full complement of human variable regions. The prior art mice had it all. They had, of course, the human constant regions as well. So, in my friend's way of looking at it, in terms of combinational diversity, they were as good as you can get. But they were immunologically sick. No amount of diversity in the number of V segments or any others helped with that problem.
But don't you want the diversity and an answer to the immunological sickness? So you want an answer to immunological sickness because otherwise the mice aren't producing the B cells which are sufficiently effective. But you want the diversity because it's only when you get the full human diversity in the variable section that you're generating sufficient B cell variants which are going to find matches with the antigens.
Your Lordship is right that you would ideally like more in, if possible. Your Lordship's not quite right in saying that it's only when you've got them that you get the sufficient variety, and I'll explain why. But your Lordship is absolutely right in saying if you were given a wish list, what would you prefer? You would like both. But the point I'm making here, my Lord, is that they are independent. They are separate. And,
right. And I think what I'm questioning is whether it's right to look at them as independent and separate when you're looking at the claim, which is to a product, the mouse, with potentially the full range of human variable genes.
the reason it's right to look at them as separate is because although both aspects that you've identified may be features of an actual mouse, the invention, the technical contribution, is that which you get from the reverse chimeric locus. It solves a different problem in a different part of the body. And really what my Lord is pointing to is the possibility that you can have an improvement by having greater diversity fed in. And I'll show you, for instance, it was accepted by the evidence quoted in the Court of Appeal from my learned friend's experts, that you still get a useful repertoire from a smaller quantity of V regions. You still get a...
But I don't think that was if the V regions are just 4 or 5.
It is, it's the mini-gene. I'll show you. It's the mini-gene construct. It's the evidence relied upon as to doing the mini-gene.
Right.
And
is that the footnote in Professor Plo's?
I've got it in mind in a reference to the Court of Appeal. Let me just tell you why, because I understand why my lords and my lady are anxious to get at it, but let me tell you why. What's actually going on, I can't resist telling you where I'm going, but what goes on in the immune system is a system whereby there is a rapid amount of mutation that goes on and a degree of natural selection to actually make better and better antibodies. It's a mini process of evolution.
That's called recombination.
No, it's called somatic hypermutation. It's part of the process of affinity maturation. But that's actually what you want the mouse to do. And why I say my friend's point is only concerned with what you feed in, he's concerned with the variety of the starting materials that you feed in, upon which this immunological system works to achieve greater and greater specificity in the antibodies. Now that's trying to give it to you in a very quick nutshell, but you get diversity from this mini evolution principle that goes on in our cells. You get better and better antibodies, the bad ones die off and the better ones reproduce. But I'm going to take it slowly because it is important for your lordship to understand.
But just to register, so, and you can deal with this concern when you come to it. As I understand it, that process is going to be better the greater the possibilities of combination that you're feeding into that system. I mean, in a sense, on my understanding, the very fact that it is an evolutionary system, speeded up, as you say, means that it's going to benefit from a greater number of
Starting points.
But when we talk about starting points there, I believe we're both talking about the combinations that are produced rather than the actual V genes being fed in.
Well,
and you're going to get the greatest, just to finish the point, and I'm sure you'll tell me why I'm wrong or answer it. The reason you get the greater number of combinations is because you're able to start with the human gene variable element with more V genes in particular than was capable of being produced under the invention as disclosed.
Perception is more is better. The question of how much better is a different thing, though, because what your lordship's really saying to me is that you've got this process by which mutations occur, which drive you to better antibodies. If you've got a greater range of input material, you might be closer in terms of number of mutations to get to the good antibodies. But how much better, we don't know. But your lordship's absolutely right that there is a perception that greater number of starting points is a desirable thing.
And when you say a perception, on my understanding of the evidence, it was the perception at the priority date.
Yeah, absolutely.
So that's what basically everyone
absolutely.
thought.
But what your lordship's identifying is an improvement. You're identifying an improvement.
What? So if you've got a mouse which has all the human gene variable section, that undoubtedly would be an improvement against that background.
The question is whether the technical contribution of having the reverse chimeric locus is a principle of general application that applies regardless of how many inserts you've got. So I absolutely don't shrink from the fact that there's an improvement. Don't shrink from it. But it's building upon our invention, and the reason I've showed you that the ones with the full complement didn't work before, because you're in effect going to one with a full complement, didn't work.
Sorry, are you talking about the prior art? But that wasn't a form of what was described in your claim, because they didn't have the combined sequencing.
Exactly. But the simple point I'm trying to make to my lord is that it's the invention that avoids the sickness, not the combinational diversity. The combinational diversity may give you an added benefit, which is what my lord's putting to me.
If I can just try a domestic example, I find that I can make a cake combining these ingredients and heat. I do it with a small amount. It works. I can now do it with a much bigger amount. It's the same technique that's being used.
Well, yes and no, but to be fair to my Lord Sales, you're saying that actually you get a better cake. It's not just a bigger cake. So
yes, I see that.
So you're getting a a better cake as well, but you're still using the invention that's necessary to get the cake. You don't get the cake at all if you don't have the reverse chimeric locus. That's the point. But I'm hoping that you understand it in more detail when I get to it, because it is very difficult to just jump in and try and give it to you in 2 or 3 sentences.
And would it be fair to say you're looking at two quite distinct goals? There's the goal of producing good combinational diversity, and there's the goal of producing immunologically healthy mice, which react quickly to antigens of a wide variety when inserted, when they're presented with them.
Yes, that's exactly my point. They're two different things that can go on in the same product at the same time, but you can have an invention to one, and somebody else can come along and improve on the other aspect. Doesn't mean they're not using your invention, your principle of general application. But my Lord Briggs is absolutely right. They're two different things that you're trying to achieve with your mouse. But I accept the point that you put to me, that greater diversity in starting material, likelihood that you might be better off in what you get out in terms of...
All right, let me just pursue it once more. Why isn't the claim then a claim to be able to do both those things to the maximum extent? So you're claiming that you can produce immunologically well mice at the same time as you're producing the full band of the variable human element in the sequence.
Well, because they are two separate inventions, and you would have to then do both to infringe. So someone would come along with half the V regions, for instance, and say, I don't infringe because I'm not doing both.
No, but your invention is the mouse.
Yes.
Is a mouse with, as I'm understanding what you're saying now, 2 features. One, it's immunologically well, and 2, it can produce or contain the whole human variable element in the gene sequence.
Well, it may or may not do that. I'm not...
But that's what it's claimed. That's the claim covers that.
Claim covers it, yes, but that's like any improvement situation. The claim covers it because it doesn't say anything about it.
And the odd thing is the claim doesn't expressly pursue either goal, because a mouse producing hybrid antibodies, one wonders why anybody would want hybrid antibodies who could find a mouse that just produced human antibodies efficiently. Your problem is that the old mice didn't produce purely human antibodies efficiently. Why do you want hybrid? You then got to subject them to other processes to take the murine bits out before you can use them on humans.
Now, let me explain. Well, I'll better let Will your lordship bear with me?
Yes, I will.
That is part of my explanation.
I'm just telling you what my problems are.
I understand. Can I give you the headlines on some of the other cases before I go to the detail? Just on the inventions involved. Detergents Unilever is a case concerning the use of a feature described by function, where the function was in fact simply causing a desired effect. The key feature was an additive that caused a chemical composition that didn't ordinarily form a particularly desirable structure spontaneously, and the claim was basically to any composition where you'd put an additive in that worked. That's what that case is about. And this is an example of cases which are fairly common in this area of the law, where the patentee simply adds some beneficial function or functional property to the whole claim and seeks to monopolise all ways of achieving it. The Novartis and Johnson & Johnson case that my learned friend Lord Panic took you to was an example of that. Pick something out of class A, pick something out of class B, put them together, and if it works, it's within the claim. If it doesn't, it's not. And it just gives you a research project. That's the headline on that. Fuel Oils Exxon is a case where the prior art oils suffered from a problem of filter clogging due to the wax crystal forming and blocking in the filter. The claims attempted to claim any oil where the crystal size in the oil had been reduced to avoid this filter clogging. And even the claim with the narrow range was not allowed because the technical contribution disclosed, that's really important, the technical contribution disclosed would have been understood as dependent upon and requiring the additive being described. The reasoning in the case is based upon the construction of the teaching in the document. There's a key page where there's lots of things emboldened, which I don't think my learned friend took you to, but it's because what was disclosed would be understood as requiring an additive, and then they were taking it out of the claim. Now, Kieran Amgen, that's a domestic case about making a protein, which rather confusingly is called EPO for short. It existed in nature, and consequently the gene also existed in nature. It was a known desirable goal for manufacture by pharmaceutical companies. And as I think you know, the case is primarily concerned with claim construction for the purposes of infringement. And the point was there were two very different ways to make EPO, one described by the patentee and one not. And the patentee's argument on infringement was basically to generalise out, not as a matter of drafting a claim, but as a matter of construction argument. And they generalised out basically to the gene information, the sequence. So to the discovery as such of the information about the thing that existed in nature. That abstract thing, stripped of any practical detail, is not a technical contribution, and indeed Section 1.2 of the Patents Act declares that discoveries as such are not inventions. So that's another case where the argument amounted to generalising out to something that was not the patentee's technical contribution. On the other side of the coin, the Nabisco Brands case was a case where the technical contribution was identifying that enzymes useful for preparing fructose, which is a sugar, could be cultivated in a particular class of fungi and used in the claim process for preparing fructose. And as I think you've seen when my Lord Panic took you to it, the particular preferred strain in that class were identified and deposited for public access, but they had not been available. That didn't matter because the technical contribution was a principle broader than the use of those specific strains. And the case referred to Genentech, which you've seen a bit of, and that was a case where the patentee invented a general principle for using plasmids to control the expression of foreign polypeptides in bacteria. The method was a method of general applicability, working equally well with any plasmid regulon, which is a structure that regulates expression, or bacterium. And it would also work with other polypeptides, including those known to exist at the time, but could not have been made because the gene wasn't known. What you had to do is insert the DNA into the plasmid. And the claims were to the plasmids. The plasmids were the products that could be used in this general methodology, and to the bacteria that had been transformed by the insertion of the plasmids. And the claim, the general broad claim, was allowed in that case because the technical contribution was equivalently broad. The headlines, my lords and my lady, is that Unilever, Novartis, Kieran Amgen, fuel oils are simply cases where the claims are not commensurate to any disclosed technical contribution, and Nabisco and Genentech, they were. Now, can I turn to the detail of the invention itself?
Just help with Exxon before you move off from it.
I'm going to come back to it.
Fine.
So that was just the headlines. I want, first of all, to outline the very important practical consequence of Regeneron's invention. We know antibodies are useful in therapy. Increasingly, modern medicine is looking to immunology. the invention in this case is to a mouse that is critical for use in the development of therapies against any kind of disease or condition where antibodies may be considered useful. Inventions like that are often referred to as a platform. I don't ask you to turn it up now, but Mr. Justice Henry Carr used that word to describe it in the very first paragraph of his judgment. The reference for you is Core Volume 2, Tab 5, MS 266 in paragraph 1. It's about 6 lines down. And they are used as platforms to develop the therapies. The invention provides a crucial tool in doing that, and it can be used again and again for many different therapies. And it means that much more efficient development of antibody therapies can be undertaken, meaning less space, fewer scientist hours and so on, or if you've got the same amount of space and the same amount of scientist hours, more projects undertaken. But crucially, it also allows development to be carried out more rapidly. This is an area that can really matter. There are instances where developing therapies are literally a life or death race against time. You'll have seen that we mentioned the Ebola crisis in our case. That's paragraph 8, subparagraph 8 on MS 122. And you won't be surprised to hear that mice incorporating Dr. Yankopoulos' invention have recently been put to work in the race to generate antibody therapies against the coronavirus. But of course, it's not just these headline-grabbing instances. Many, many different diseases may be targets. So what's all the fuss about? What you really need to understand is basically it's the immune system, I think I can start with. It's a remarkable thing. And when you've understood it, the basics fall into place. My learned friend, regrettably, didn't tell you about key aspects of it. And in particular, he said not a word about the parts of it that are relevant to understand what the reverse chimeric locus does for the transgenic mouse. I know my lords and my lady understand the body needs to be able to react to practically an infinite variety of possible foreign bodies. So it needs to be able to produce antibodies. But the range is enormously wide. And in fact, our genome does not code for the range of antibodies that we are likely to need. It's not just us, in fact, it's our progeny and their progeny. And it doesn't do so even in the variety of antibodies that you might be able to theoretically say exist by combining the various combinations of V's, D's and J's. That is no doubt a large number, although not all of the segments are functional, so it's not that large. But it's still not large enough. And the reason we need to use a mouse is we need the immune system. We need the immune system to be set to work. Now let me tell you how it works. You know that antibodies are polypeptides made from B cells. And you know that the ends of them, the variable regions, are the key bits that make them specific. And you know from what my learned friend described is that those are contributed to, at least in the initial B cell, from DNA that comes from a V, a D and a J. But the immune system is much more than just doing that. The system is one such that the cells develop and proliferate in a way that causes the antibodies being made to become more and more specific to the foreign body. You've seen the diagram of the antibody. Mr. Purvis showed you that yesterday. And he told you about the recombination. He called it somatic rearrangement. Somatic rearrangement. But that's only the first part of the story. And it's not why you need to use the mouse. I think you know that the normal rule is a protein that your body makes is coded for somewhere in your genome, and it's in every single cell. That's the normal rule, but that's not how antibodies work. The DNA coding for a specific antibody is actually the end result of B cell development and a maturing process. And the key process is the affinity maturation that comprises a process called somatic hypermutation. And my learned friend, Mr. Purvis, did tell you about that very first step, the rearrangement that he explained. And if you look in the agreed primer, so if you look in Core Volume 2, Tab 9, MS 439, I'm looking at paragraph 5.2 in the middle of the page. This explains the creation of immature B cells. And it happens in the bone marrow. So paragraph 5.2 in the middle of MS 439. This happens in the bone marrow, and this is where the rearrangement occurs that my learned friend explained, which is actually elaborated further in paragraph 5.6 of this document. And that initial process results in a cell with a combination of specific V, J, and Ds, which can then display a receptor on its surface. And that receptor is simply a version of its antibody bound to the top. You see that referred to in the penultimate line of 5.2. And you see from the first 2.5 lines of para 5.3, at this point it's called a naive B cell and leaves the bone marrow. And off they go into their big wide world, travelling via the blood to their destinations, which we shall see shortly are structures in the lymphatic system. That's the end of my learned friend's account, the creation of the naive B cell. But if you look at paragraph 5.3, it goes on to explain the way the immune system works is that the B cells need the antigen to be present to be what is called activated by binding to the receptor, i.e. the copy of the antibody bound to its surface. And when that happens, they can divide and differentiate. And importantly, for our understanding, they rapidly undergo many mutations. You see these mutations sustained in the process of maturation, mentioned in the second half of paragraph 5.3, about 4 lines from the end. And the really helpful thing about this particular passage in the agreed primer is it puts its finger on the button in describing it as a form of natural selection. Do you see that in the penultimate line? There's a bit of jargon floating around here, but the key thing to see is this. The bone marrow is where the naive B cells are made and sent out into the blood to different destinations. And the B cells will undergo the process of maturation, which includes this process of mutation and natural selection. And that's why I say it's basically like a mini evolution going on.
Is that what paragraph 5.3 calls divide and differentiate? I'm just looking for the reference to mutation in that paragraph.
Sustained mutations in the process of maturation. 4 lines from the end.
Oh, I've got it. Yep, thank you. Yes. Although, funnily enough, that's just described.
I think
That's a description of the ones that go off and die.
Yeah.
Well, it happens in both. That's what natural selection's about. You have mutations. Sometimes it's good, sometimes it's bad. And the rub is, if it's bad, you die. I'll show you a diagram later on, but that's what's going on.
The antigen is something like a virus that you want.
Yes,
Yeah.
the antigen is actually perhaps a protein on a virus, so it's not the whole virus necessarily, and that's why there were two in Biogen. There were two antigens to the same virus.
But I mean, sorry, you go on. I want to, well, say, it seems in 5.3 that what you need is a stream of naive B cells which are coming out of the bone marrow, and some of them will bind on antigens, and then they're the ones that will be picked up by the body and developed, but others won't, and therefore won't be developed. So I just wonder whether it mightn't be said that, in a sense, I appreciate it's not mutation that's going on in the bone marrow, but it's what's going on in the bone marrow which is producing the wide range of potential B cells, which might, one of which out of, I don't know, thousands, millions, I don't know what the numbers are,
It's definitely
bind upon an antigen, and then when you hit lucky with that one, the body starts reproducing that one, and it becomes effective.
Well, it doesn't just reproduce that one, that's the whole point, but I will show you that...
But anyway, the point I was making is that that's a little bit, on my understanding, a bit different from what you were just saying, that it's all a process of mutation to get the good ones.
I understand what you're saying, and really what you're saying is that if you don't have something that's good enough to bind at all to start with, you might not start the process off, and I understand that that's a...
Is that a correct understanding?
Well, I'll show you what their expert said about the mini-gene giving you useful repertoire, so I'll show you that. But I do understand what you're saying. You're suggesting that if it's so narrow for a particular antigen, you might not be able to kick the system off at all.
Yes, I mean, my understanding from that is you want the widest range of naive B cells that can be generated to be coming into the body on the basis that statistically that's going to improve your chances of binding to the antigens which might kill you.
It definitely improves the chances of having them closer in terms of mutations to the really good ones. But let me fully explain the process, because you'll see that it's far more than just the rearrangement at the beginning. And just stand back and pause. What's absolutely key is to understand that immunology works by the same forces as Darwinian evolution. And the point of the mice is to harness their immune system to do this work for us. And the primer contains more detail of this, and this is in section 6 at 455. Which covers this somatic hypermutation and something called class switching, which is something concerning changes to the class of constant regions being used as well. And you see...
You say 455?
MS 455, section 6.
445.
Oh, sorry.
I'm going to say
Yes.
we're into something different by then.
445.
445.
Section 6.
Right.
And as you see in the first paragraph, 6.1, they're dealt with together at this point because they both take place after the initial VDJ recombination and are controlled by similar signals. And it's explained in 6.1, these processes take place in the lymphoid structures. And you actually see the diagram, the lymphoid structure, at the foot of page 466. 446, I'm doing it again. 446, do you see that diagram? And in that diagram, you see the naive B cell being fed in on the left. That's the cell that comes out of the bone marrow. So it has a particular VJD region in it. And what happens is, at first, it's subject to reproduction, called clonal expansion. And then the hypermutation. That's the mini evolution, which will lead to improved affinity or not. And what you see depicted is the disadvantageous mutation, the arrow going down to a rather shriveled dying cell called apoptotic. I think that's how you say it. Probably got it wrong. But the other ones, you get improved affinity. And eventually, they may end up as either memory B cells or plasma cells, the latter of which are the ones that churn out the antibody in the plasma. And as an aside, memory B cells are the point of vaccination. You give your body a head start in this process before actual infection. And the Darwinian nature of this is rather helpfully further explained at 6.7 on MS 447. You see right at the end of the paragraph, the comparison made expressly, affinity maturation is best compared to Darwinian selection. So that's the basics of the immune system and how antibodies are the result of this affinity maturation process, akin to the mini evolution. And I think you understand that if you've got a healthy immune system, you'll end up with a population of varying B cells. So although all antibodies made by one cell are identical, and in fact it may reproduce so there are many copies of a mature B cell, also making the same identical antibody, there will be a population of varying antibodies being produced in a mouse. And for therapy, one wants a single thing, ideally. And this picks up on a point that my Lord Briggs made to me. You're not actually contemplating, excuse me, you're not actually contemplating using a mouse to actually manufacture quantities of antibody to put into your eye. You're not doing that. That's why this is just a development tool. What you want is a single antibody, and you do that by making monoclonal antibodies. And that's a very well recognised process dating back to the mid-70s. For your reference, it's dealt with by Mr. Justice Carr at para 10 of his judgment on MS 268. You don't really need to know the details. It's a way of fusing a cell with a cancer cell, which then reproduces forever and gives you an immortal line of cells, all producing the same antibody. But that's how you produce the product that gets put into your eye. The point of the work you do in the mouse is to do the development work on the B cell to get the finished B cell that's gone through this process of evolution, and you're basically using it to identify individual B cells. That's what the mouse is doing. You're putting the mouse's immune system to work to proliferate and mature B cells producing antibodies. And of course the DNA in each will be slightly different. They'll each be a candidate for therapy if you put them into a monoclonal antibody system. But the mouse, the reason you need the mouse is you need to go through this evolution system because the coding for any particular antibody isn't in the genome. Even if you were to just try to make every combination of V, D and J, it's still not there because it's been through this hypermutation process of natural selection. So the central idea is that you need an immune response of an organism to do that work for you. You're putting the immune system to work to do this job. Now, my learned friend has mentioned why you can't just inoculate a mouse and use a mouse antibody, and that's because of the hammer response, the human mouse antibody response. And for your reference, it's Mr. Justice Carr at paragraph 9. So that's why we use a transgenic mouse. The idea is to use the mouse's immune system to do the work on the human DNA that's being fed in. And as you know, the unidirectional way the art was seeking to implement the idea was inserting all human DNA. And that was the big problem. And you've seen the problem and Dr. Yankopoulos' unchallenged evidence set out in the Court of Appeal judgment. I'm not going to ask you to turn it up again, but it's paragraph 34 of that judgment. Actually, having said I'm not going to ask you to turn it up, I am going to ask you to turn it up because of the next. If you go to Core 2, MS 183. In fact, the paragraph I was just referring to is on MS 182, but the reason I'm asking you to turn up is to show you what Kymab themselves have said about it. This is a paper quoted in the Court of Appeal where they recognised the unexpected advantage of the reverse chimeric locus. And the extract is at the bottom of the page, and the really important bit is the last two-thirds of that quote about the so-called first-generation mice, from the words "in addition." And as you see, they identify the first-generation mice had both human variable and constant regions, i.e. fully humanised. And they say one would expect them to produce fully human antibodies, but they point out that there are sequence differences between human and mouse constant regions and signalling proteins, and as a result, during the stage when the antibody functions as a B-cell receptor, that's from the point it leaves the bone marrow, they explain the interaction between the human constant region and the mouse signalling proteins may not be optimal, and reduced signalling could limit antibody class switching and affinity maturation, as well as B-cell differentiation into mature antibody secreting plasma cells. The key thing is they've identified the two processes that you saw as taking place afterwards, the class switching and the affinity maturation which is affected. Nothing to do with diversity. They're identifying the problem that happens in a different part of the body. It's both of those processes we saw using similar signalling in the lymphoid structures. Before I just show you how it's described in the patent, because it's very similar, I just want to pause and make sure you've got the basic idea. The basic idea is to get a humanised antibody. And now we have Dr. Yankopoulos' contribution. We know the way to put the immune system to work is to, or what we have to do, is to include a human variable region as it goes through the affinity maturation process. We know we need to do that because it needs to be the subject of the mutations. But we also know that we need the mouse constant region whilst that is happening. And we don't need the human constant region. Fortunately, you can replace them afterwards. And that's straightforward, as Mr. Justice Henry Carr explained in the last sentence of paragraph 1 of his judgment. And so the way to get fully humanised antibodies is to use the immune system operating on this hybrid half-human, half-mouse locus. That is the substance of the idea that is disclosed in the patent. And you see that, I'm going to refer to the 287 patent just because that's the paragraph numbers that we see in the Court of Appeal judgment. 287 patent, so MS 368, paragraphs 115 to 117. The first of these paragraphs tells us transgenic mice produces hybrid antibodies containing human variable and mouse constant regions. Specifically tells us there's a direct in situ replacement of the mouse variable region with human counterparts. That's telling you it's going to make the mouse immunoglobulin locus creating a hybrid. And the last sentence refers to them as resultant hybrid immunoglobulin loci. The beginning of paragraph 616 explains that they can be made fully human subsequently by replacing the mouse constant. And you see the second half of paragraph 116 of the 287 patent, the explanation that the antibodies generated by the new mouse will retain murine FC regions. That's the constant regions in the polypeptide expressed. And it's said that the mouse FC region, will interact more efficiently with other components of the mouse B-cell receptor complex, including signaling components required for appropriate B-cell differentiation. And the key thing is the last sentence of this paragraph. These interactions are important for a strong and specific immune response for the proliferation and maturation of B cells and for affinity maturation of antibodies. That's the Darwinian evolution. That paragraph is key.
But just before you leave that, can you look at paragraph 114 on page 368, which appears to suggest that the idea of using chimeric antibodies wasn't new because it had been suggested in 1998. What was new, or what they're putting forward as new, is a methodology for making such chimeras. In other words, the magic isn't chimera and eureka, you've solved your sick mouse problem. The magic is how to get to a chimera which will solve your sick mouse problem by a technique which enables you to produce it.
Well, I looked.
I may have misread it, but I'm only looking at one paragraph out of 100.
No, I can tell you.
I just
when I read
stumbled on it.
I can tell you when I read it, I had the same reaction, so I asked about it. Now, I understand. I think that document that's quoted is the Longberg prior art, and certainly I understand that what that is talking about is something that happens actually after. It's something that happens in something called class switching. It's called trans switching, where what happens is you've got
What it says.
you've got something where they've actually inserted the whole human region in a different place, and what actually happens, class switching is where the constant regions switch around at the end. And as I understand it, what happens is the mouse constant goes to where the human has been inserted, but it's after the maturation. And so it's in a different location. It's not in the murine locus. It's to do with constant regions being replaced, not variable. And indeed, it happens at the wrong point in time because it happens later. And certainly as I've understood it, that document was one of the prior art attacks that, in fact, my learned friend dropped. On paragraph 5 of Mr. Justice Henry Carr, MS 267, Lomberg was abandoned. And so you're quite right, and the way that it's described there, it may look as if there was more to it, but it was a very different thing that was actually being described. and has nothing to do with curing the mouse or avoiding the mouse sickness, because it happens at the wrong end of the process and in fact in a different place. And I think only happens in the heavy chain, whereas the claim requires both heavy and light. Yes, I think you know this, but just for completeness, the paragraphs I've just been taking you to, and indeed the paragraph that my Lord Briggs has just asked me about, appear one number out in the 163 patent on MS 412. Now, can I very briefly address, see the time, my learned friend's point on the quantity of DNA that's inserted? Because you know the Court of Appeal has held that the skilled person could have implemented the invention using the common general knowledge on the basis of the disclosure of the patent by one of two routes. The first was a mini-gene approach, and that's the use of a much shorter sequence of DNA that is some combination of V, Ds and Js, or in the case of a light chain, just V and J. And the basic point is that actually in the real-life gene, these are spaced out, and what happens is, or what you can do, is to chop out the non-coding regions. They're regions a bit akin to introns that we see in the Biogen case, and you can construct something called a mini-gene, which is much smaller, with a selection of V, Ds and Js. And that could be inserted into the locus using common general knowledge technique called homologous recombination. And that's just a fancy name of putting arms on that make it stick in the right place. And it's noticeable that it was all part of Kymab's own evidence. They were running an obviousness case, positively asserting both that the idea was obvious and it could be achieved using common general knowledge techniques. So if you turn up the Court of Appeal judgment, you see the point about the evidence coming from Kymab itself on MS 212. So I'm in Core 2, MS 210, sorry. And I'm right at the foot of that page, paragraph 177. And the two experts were Professor Stewart and Professor Howard. And you get a feel for how this works if you look over the page at MS 212. This is an illustration from Professor Stewart himself. The blue is the mouse DNA, where the human mini-gene construct is shown in red. And you see it's inserted where the J regions are. And importantly, Professor Howard, Kymab's other expert, was saying the same thing. You see that recited in paragraph 184. And this is the bit that I promised my Lord Sales. You see there that he was also saying, this is Kymab's own expert, that the skilled immunologist would have understood that a useful antibody repertoire could be achieved from a subset of the variable gene segments.
So, a useful.
Yeah.
So there may be very many different degrees of usefulness.
Like there's different degrees of usefulness of the television or the aeroplane, there may be an improvement to be had, but you can make it, you'd expect it to work. And so Professor Howard was also saying that the skilled team could have used a mini-gene construct. And I don't need to take up time on the LT-VEX. There's a similar point where you just used a shorter sequence. So it was a slight modification to example 3. I think you've seen the figure at the back of the patent where 2 LT-VEX are taken from each end of the large cloned bit of DNA. And the Court of Appeal basically concluded that you could do it that way as well with shorter segments. And I'll just give you the reference. It's summarised in para 207 at MS 219. And the conclusion there is several V segments is possible. The upshot, my lords and my lady, is that there are two goals going on. You have the need for the healthy, efficient immune system, and you have a desirability of having as many human variable regions being fed in at the start. But they are two different things. There may be that any individual mouse will embody both, but they're two different things. And they're happening, they actually relate to things happening in different parts of the body. The healthy immune system, the need for the mouse constant region is all to do with the signalling that goes on in the lymphoid structures that we've seen, the efficient evolution that goes on, and the rearrangement part of the picture, it goes on earlier. That goes on in the bone marrow. But I entirely accept the point that my Lord Sales put to me, is that a greater diversity of input may be thought to lead to a greater diversity of output. But it isn't entirely random what's going on there. You've got this Darwinian force creating better and better antibodies, whatever the input. So you've seen the evidence from Kymab's expert that you'd expect a useful repertoire with a smaller subset. It's not the improved version, but it is the inversion with the healthy immune system, which is necessary. Without it, even if you have all your V's, D's and J's, it doesn't work. Two different things. Now, my lords and my lady, I've got several cases to look at, so I was going to move off of that, unless you've got any questions on the technology, the science. I was going to go to detergents first. That is Authorities Bundle 4, tab 34. And it's about compositions for liquid crystals. A liquid crystal is a liquid that forms structures within it, akin to the kind of thing we see in solid crystals. You've probably an idea of how a detergent works. They're molecules that are partly hydrophilic and partly hydrophobic. We use them in cleaning agents where we want the phobic bit to stick in some dirt, say something fatty, and then we want it to mix with the water, so you've got the hydrophilic bit as well. So they're often called surfactants because they tend to form a layer around a surface. And this was about surfactant systems that didn't form the required structure. Surfactants can form structures where you've got, the simplest one is a micelle, where you've got all the hydrophobic bits pointing in and all the hydrophilic bits on the outside. So you get a little circular thing that floats around. But that's not the only structure that they form. They can form things that look a bit like straws. So it's the same thing. The bit that doesn't like the water is pointing in, but it's actually extended up like a cylinder. And the structure that it might form when it does form straws is called a hexagonal phase, which when you look down on the end of it, the straws are arranged in a hexagonal lattice. And so it's a liquid, but it's got these structures of surfactants in it. And this is all about hexagonal phase forming. And you can see the claim in the case on MS 2341. And basically it's to an aqueous detergent formed into a hexagonal liquid crystal gel. You see that right in the middle of 2341. And the first subparagraph is simply that it's got to be a surfactant system. Don't worry about the craft point. It has to be a surfactant system. And in fact, it can be formed of two different surfactants. And paragraphs little a, little 1 and little 2 are just describing basically the hydrophobic or the hydrophilic part of it. But the important bit is in subparagraph A, just below halfway, the system being incapable of forming hexagonal phase spontaneously. And if you go down to the second thing that's in this claim, B, is an additive, and I'm going to come back to that, but just cast your eye down to C, you see water. So basically it's the surfactants that don't form the hexagonal phase, and the additive is basically one that doesn't form micelles itself, but causes the surfactant system to form the preferable hexagonal phase. So the claim is to all and any surfactant compositions that has this known desirable property, or at least those that don't do it spontaneously if you've achieved it by putting an additive in. That's it. And in fact, it's probably even worse because it looks from the words excluding as if somebody, I'm now looking at excluding on MS 2342, somebody else had actually done one and they were excluding that one. Now, if you go to the reasons for the decision that starts at MS 2347, you see the dispute identified at the foot of the page, where you see questions whether the subject matter of the claim as a whole can be carried out because one of its essential features, the additive, is defined only by its function. And they say the test for sufficiency is the same whether the claim is in structural terms or functional. That's the first full paragraph on 2348. But then, if you go forward to 2349, the para just around the middle is the point to be established. So I'm in the middle of the page, the point to be established is whether or not the specification disclosed a single embodiment or technical concept fit for generalization, which makes the available, the host of variants encompassed by the respective functional definition. And you see the rest of the paragraph was that it admitted that identifying the compounds other than hydrotopes that could be affected to bring it about couldn't be identified. So they were in trouble, as you see from the first sentence of the next sentence. They simply invited a research project. And if you go to paragraph 2.2.2 on MS 2350, what you see is that the respondents had referred to several earlier decisions of the Boards of Appeal suggesting that as a matter of principle, one way always satisfied the disclosure. I'm now looking about 4 lines into paragraph 2.2.2. And what you then see after that is an analysis of the cases that had been put forward as establishing that. The first is Genentech, which you've already seen described over the page on 2351. And the upshot on that case, so I'm in the middle of the page where it says similar findings concerning the remaining functional definitions. Do you see that? Middle of 2351. The upshot is it didn't support the broad proposition that one way is always enough because it was dependent upon the findings in the case. That doesn't mean one way wasn't enough in that case. It was because it was specific to the nature of that case, exactly our position. And then you see the rest of the decisions referred to from the end of that, where it says similarly the reasons. There's a series of other cases that were relied upon, which just didn't apply the rule at all. And if you go forward to the next page, 2352, what they're talking about in the middle of that paragraph, where it says, on the contrary, these decisions are all based on the common ground that disclosure of the invention is only sufficient if a skilled person can reasonably expect substantially all embodiments of the claimed invention which a skilled person would envisage on the basis of the corresponding disclosure and relevant common general knowledge can be put into practice. What they're talking about there is these other decisions which have applied a different rule. Now, I've also got to deal with Exxon and fuel oils, which is at tab 33 of the same bundle. The claim is in the middle of page 2321. Basically to a fuel oil with a range of particular boiling temperatures and wax content. And if you go to 2322, you see that what the board actually considered to be the more important reason, I'm right at the top of the page, was that the subject matter wasn't, more important reason was that the claim as a whole didn't define, i.e. state all the essential elements of the matter for which subject protection was sought in terms of technical features. And you see the points made by reference to document 1, which you see from 10 lines down, was a French prior art document, where it was mentioned that the need to have small crystals as small as possible to prevent cold filter plugging. So it's not a really promising start. It doesn't sound like rocket science, having a filter blocked in the cold by crystals to suggest they should be smaller. But the key part of this decision is, if you skip over to MS 2323, the first full paragraph, one of the arguments on the appeal was that document 1 didn't disclose the principle underlying the invention, the idea to make it small. That was the contention. And the absolutely key part to the judgment on the reasons is if you go forward to 3.2, which is at the bottom of MS 2326, this section, 2326 and 2327, goes through and construes as a matter of interpretation what has been disclosed. And the key things are the passages emboldened in 2327. It would be understood, the disclosure would be understood as obtaining smaller crystals by the addition of certain additives. And you see that emboldened halfway down 2327, and you see essential emboldened a few lines further down. It would be understood as essential and the whole point is summed up when it says where it says they don't define the claim subject matter to reference to all of its essential technical features, about 8 or 9 lines up from the bottom of that paragraph. And the key thing to understand about this and the reason that you have, for instance, the passage that my learned friend likes on paragraph 3.6 is that this decision turned upon the construction of that document. Even if small crystals had have been novel and inventive, that wasn't what they were disclosing. I mean, they clearly thought that it wasn't novel and inventive anyway, but that wasn't what you were disclosing. Now, the very last thing, if I may, in absolute breakneck speed, is to refer to the claim in Genentech, just to make sure that you've understood. This is Authorities Bundle 4, MS2280, so it's tab 31. The claim is on 2285. It is to a product. It is to a product that can be used in the general methodology, but it's an agent of the product. So it's product claims, and it can be used to make foreign DNA, foreign polypeptides. Two things about that. Just like our claim, it has that ability to be used in a process in it. Ours is the mouse to make hybrid antibodies. The second thing is, not only were all the future bacteria and so on not possible, but the DNA that you're inserting, you could only insert the DNA into the plasmid for polypeptides that were known and you knew the DNA sequence. So there were there were polypeptides that you knew about that you couldn't make even using the bacteria, Regeneron and plasmids that were specifically identified. And the whole point about this is it's a method of general, it's a principle of general application. It happens to be a method, but it's in, what comes with it is agents that you can use in it. So they were products that were claimed. It's just like ours. Now, I've taken that at a breakneck speed. I hope you understand.
Yes, we understand. We have your written submissions, and we're obviously going to go through this at greater leisure and with greater care. Thank you very much, Mr. Speck. Mr. Purvis.
Oops, I'm sorry, I'm going to mess up the transcript again. My Lords, my Lady, I'm going to try also, at probably breakneck speed, to cover a number of the key points made by my learned friends. Can I kick off with the policy points? Our primary position is that this is not a matter on which this court can or should properly strike out on a new course, contrary to the established approaches on breadth of claim enablement as a result of nebulous policy considerations, let alone a kind of cri de coeur of the sort you've heard from Regeneron in this case. Clear rules are needed in patents to be able to implement the system, and sometimes one might look at them and think, well, perhaps that's a bit unfair. Sometimes one might look at them in a different way and say, well, perhaps you were lucky, you got something which was quite generous. The Edison case was mentioned, I think, the electric light bulb. Perhaps it seems a bit unfair that he couldn't claim all electric light bulbs, having made the first one, but he was limited to his particular filament structure. The Biogen inventor, Lord Hoffman, suggested afterwards that given the genius of his approach, the deprivation of monopoly may have seemed slightly unfair. The generics of Lundbeck inventor, on the other hand, could be regarded as having got perhaps rather too much protection, given the nature of what he'd actually achieved. The fact is, you have to have rules, and they have to be abided by. Regeneron, we would submit, in their approach in this case, are essentially saying the established rules shouldn't apply to us, or the rules should be changed to allow our patent to survive. But the rules are soundly based on policy, and that should apply in every case. And we submit, actually, this case is a very good illustration of one of the main purposes of the policy. And I note that Regeneron's case on policy, at 14.1a of its case, kicks off with the importance of incentivising the publication of knowledge, which we agree is a key policy consideration behind the requirement of enablement. And my Lord Panic made a similar point in his oral submissions. There's a very good reason to require a patentee to have fully disclosed and fully enabled across the scope of the claim, because there's an inherent tension between the innovator and the state. The innovator would like to disclose as little of its knowledge and expertise as possible in order to maintain a position of advantage when the patent expires. But the breadth of claim enablement requirement obliges them to hand over the keys to exploiting the monopoly, not just at the worst end of the claimed range, but also at the best end. And that's plainly a good thing. In the present case, we ask your lordships and your ladyship to imagine that, contrary to the fact, Regeneron had in fact invented the McDonald-Murphy technique, which they came up with, in fact, in 2003, before the priority date. And they had in fact produced a mouse using that technique with the complete repertoire of human variable segments before the priority date, rather than in 2006. But they decided to keep it a secret and simply filed the specification that you've seen in this patent with its completely misleading information as to what could be achieved, and succeeded only in showing potential enablement at the very bottom end of the claim. Their case before you would be no different. According to them, they would have enabled the claim sufficiently to justify the broad monopoly without having revealed the actual secret necessary to perform it across its scope. We submit that a decision in their favour in this case would give carte blanche to patentees to provide a highly restrictive and unhelpful account as to how to implement an invention, so that you just got within the scope of the claim, but you couldn't do what you really wanted to do and what the patentee secretly knew how to do. We also submit that a decision in Regeneron's favour would validate and encourage a rush to file patent applications before the inventions had been properly implemented and the patentee himself had worked out how to produce the products within the claim and to make the broadest possible claims that couldn't be performed across their breadth. We submit that validating a rushed application like this one is unfair on competitors who may be working on the same project, but properly waiting until they know what has been enabled and what can be properly claimed before putting in a proper application with a coherent and accurate description of what can be done and what its practical limits actually are. Regeneron were a patentee who simply did not know whether the invention could be implemented and are asking essentially for a windfall for its premature filing. We submit there is no doubt, therefore, that the policy considerations behind requiring proper disclosure across the scope of the claim are valid ones and validly apply in the present case. Can I talk briefly about some of the submissions made on the authorities? The account given that by my learned friend Panic in my submission about polypeptide, and in particular his account of the way that case was described and implemented in Biogen was fundamentally wrong. The whole point of polypeptide and the decision of the technical board was that it could be performed right across the scope of the claim at the priority date. And if your lordships, my lady, have the Unilever detergents case, where polypeptide was considered by the Technical Board of Appeal themselves, which is at A4 tab 34 at 2351. The middle of page 11 characterises this perfectly. They're considering polypeptide, and you will see from about 10, 12 lines down, moreover, in respect to the functional expression suitable bacterium, which pointed out the applicability of the claim method to any kind or most species of bacteria has not been effectively challenged. 3.2.2. Similar findings of fact concern the remaining functional definitions in the considered claim, e.g. point 3.4.3. In other words, as a question of fact on the findings in polypeptide, all the functional features appeared to be perfectly workable with any choice of the available products which the skilled person might make. So far as Biogen is concerned, we submit that my learned friend never really addressed the key issue, which is the key to the result in that case, which can be seen from the quotes. If you've got A1 at tab 5, page 48 and 51 of this decision, 979 and 982 MS. Bottom of 48, reference to Genentech, doing no more than applying a principle of patent law that the specification must enable the invention to be performed to the full extent of the monopoly claimed. And then on 51 at the top, MS 982, the explanation of things that make a claim insufficient. The patent may claim results which it does not enable, such as making a wide class of products when it enables only one of them, when it enables only one and discloses no principle which would enable others to be made. That is the sense in which Lord Hoffman's using the term principle when he talks about its importance in the context of sufficiency. And we've given other references that my lords and my lady already have. Kirin Amgen I didn't refer to in my opening speech. It was, Kirin Amgen in the Technical Board of Appeal. That's at, can I just briefly take you to that, because in our submission it's another one of those cases which is on a different point, namely the allegation against the patent that the patentee has not enabled every method of making the products which are the subject of his product claim. So if you've got it at A5, which I've now lost.
Can I just ask you, that dictum you just took us to from Lord Hoffman,
Yes.
at MS 982,
Yes.
where he says the patent, talking about ways in which things can go wrong, that the patent may claim results which it does not enable, such as making a wide class of products when
Yes.
it enables only one of those products
Yes.
and discloses no principle which would enable others to be made. Now, I think
Yes.
it might be said against you that a principle has been disclosed which would enable
Yes.
others to be made. Am I right in thinking your answer is essentially the judge's answer, that what's been disclosed is the result, the RCL, rather than
Yes.
a way of making the product?
In many ways, that's a fundamental problem at the heart of my learned friend's case. Their principle is not one that enables their products to be made. It is simply a way of defining the products in one sense, and in another sense, as my learned friends also urge on you, some benefit that those products might have if they could be made. And that is essentially the point that the late Mr. Justice Henry Carr was making. And that's the key, we submit, to the difficulty that Regeneron have. They haven't enabled the making of the products. Sorry, Kiran Amjan is a very brief point, but at tab 37 of A5, MS 2454, you will see the point they were actually looking at 4.5, which is not the point in this case. It's the very point which was the result in Biogen, although the TBA are taking a different view. They say it's a fundamental principle of patent law that a claim can validly cover broad subject matter, even though the description of the relevant patent doesn't enable every method of arriving at that subject matter to be carried out. The problem in this case is plainly not that one. It's that they haven't enabled any method of arriving at most of the scope of the claim to be carried out. Briefly on the Bundesgerichtshof case, I wasn't going to say a lot about that, but you can see from paragraph 23 of that case, interestingly, that this was a decision that diverged from a decision on the same facts by the Technical Board of Appeal, which you haven't seen. This was a medical use claim involving the choice of a particular ingredient, and it's clear that plenty of ingredients had been disclosed across the scope of the claim, and others could be found by simple experiment and verification, which you can see, I think, from paragraph 29 at the end. So this was effectively the ultimate finding of fact. A number of inhibitors, which were the necessary things for the medical use, were already known at the application date. The manner in which a skilled person was able to determine if those inhibitors were suitable is described in the patent specification. It hasn't been established the experiments to be carried out for this associated with an undue burden. So they've given the recipe, they've given you a set of usable ones, and they've given you the way to find out whether other inhibitors would in fact work. On the facts, it's found that that was enough. Can I now turn to the submissions on the law made in particular by my learned friend, Mr. Speck, during the course of today? The central heresy we submit, which underlies Regeneron's case, is that you can have a product claim to a range of products without enabling products across the scope of that range to be made. And first of all, it said that that's not required, that apparent fundamental requirement in all the TBA authorities is not required where one would expect the technical contribution to, quote, work across the scope of the claim. But how, we submit, can a contribution be said to work at the priority date when it cannot be achieved across the scope of the claim at the priority date? Plainly, we submit it cannot, which is why when the UK courts and the TBA consider what is meant by enabling performance across the scope of the claim, in the case of product claims, they say it means making the products. We've given a raft of references to that, both in my opening submissions and in our written case. And my learned friend falls back on this concept of technical contribution But as, again, I made clear, I think, yesterday, every time the TBA and indeed the UK courts refer to technical contribution in the context of sufficiency, it is made clear that the contribution which is necessary to support a claim involves actual enablement of the manufacture of the products of the claim. It is a pillar of patentability that you have enabled the products to be made. And just for your note, that's clear from Mycogen, A4, tab 35, MS2383, the disclaimer PPG case at A5, tab 43, MS2662 at 2.5.3, and indeed Biogen itself talking about technical contribution requiring enablement and manufacture at A1, tab 5, page 51, MS982. We submit technical contribution cannot help my learned friend because it plainly requires enablement. And what my learned friend Mr. Speck then did was to introduce questions of the inventive advance over the prior art. And again, we submit that is something which is in no way relevant to the question of sufficiency. Whether there's an inventive advance over the prior art, how clever it is, how original it is one thing. Whether you've enabled, and if so, how much of the claim have you enabled, is another. It's a straightforward question of technical fact. Now, it's interesting to look at the way the TBA look at these cases. They look at sufficiency first, and if they find that a claim is not enabled across its scope, they stop there before even getting to consider the question of obviousness and the question of novelty, which involve establishing what the inventive advance over the prior art may have been. And learned friend then gave a raft of interesting hypothetical examples of technology that have been invented. But if one takes his first, the Wright brothers, and assumes for a moment that they had in fact invented the whole concept of heavier than air flight. Nobody had ever thought of it before. Startling idea. No one had ever envisaged such a thing. And they could say the disclosure of that idea was their inventive step over everything that had gone before. But that didn't mean that they could claim any heavier than air product which flew. They couldn't have had, on any view, a claim which included helicopters, although helicopters would, as it were, have embodied their inventive advance. And why not? Because they had not enabled anything which flew, save their actual product, and what could be made without further invention or undue burden based on the disclosure of that product. For example, they'd never enabled anything to fly without wings. And that shows very clearly, we submit, that enablement and inventive step over the prior art are completely different things. Now, my learned friend proceeded from that proposition. Yes, can I just, on that point, give you a reference which Mr. Tappin provides to me in Lundbeck and Generics, just for your note, effectively saying the same thing that I've just said, which is at paragraph 41. I'll give you the MS reference when we find it. My own friend, Mr. Speck, proceeded from that assertion to the proposition that merely providing a general principle, which was, by definition, I think, inventive, without practical enablement of products across the scope of the claim, was therefore permissible. And I think I wrote down, at one point he said this, that was because performing the invention requires the provision of the novel and inventive combination of features. So that was the pillar of his argument, that because in order to perform the invention of the claim, you needed to start with their inventive contribution. That was sufficient. We submit, no, that is again heretical. That provision of that inventive concept is not enough to enable performance across the scope of the claim. And indeed, it's the very fallacy identified by Lord Hoffman in Kirin Amgen at paragraph 116. And if you've got our case, we cite that
That's, in
and come
fact,
back.
it had to be necessary and sufficient.
My Lord has got it, yes. I won't therefore take you to it. Paragraph 68. It's got to be not merely necessary, but also sufficient. And of course, also flat contrary to the TBA decisions, for example, Unilever detergents, where the embodiments have to be able to be put into practice. And here, of course, it's important to also bear in mind what Regeneron actually say in their patent. They don't only say we can produce a limited range of non-immunologically sick mice. They say we can produce all singing, all dancing non-immunologically sick mice with maximum combinatorial diversity. They specifically teach that. And then they claim a range of mice, including that mice, and yet somehow they say, oh, don't worry, we don't have to enable it. Flat wrong, we submit, as a matter of law. Then my learned friend, Mr. Speck, gave an account of detergents Unilever. Just briefly, his suggestion that what's said on page 10 of that case was intended to distinguish previous cases, I think on their facts, is plainly not the case. What's going on in detergents Unilever, which is why it's constantly cited to this day on this very issue, is that they are unifying the approach behind a single statement of what the law is. Fuel oils Exxon, I'm going to make 2 points when you go through my learned friend's submissions, which were brief. First of all, he placed a great emphasis on page 2 of that decision. That's the account they give of the decision of the opposition division. It is not their reasoning on the case before them. And the other points he made were drawn entirely from the account in fuel oils of the objection under Article 84, not Article 83, where very different considerations apply, as the technical board themselves point out in passages that we've already referred you to in our written case. And if I can just briefly address Mr. Speck's technical submissions on the patent, he made a valiant attempt to row back, say on the patent and on the common general knowledge, to row back on the perceived importance of the need to perform this invention across its scope. And indeed initially set out, apparently to show that the technical scope of this claim didn't really matter at all because of the subsequent somatic hypermutation which may occur to B cells, which have, because of their particular combination of VDJ, already bound to antigens. Ultimately, however, as we see it, he rode back from that. He had to accept it fundamentally did matter because it's the combination of VDJ which enables the B cell to bind to the antigen and then start the process of division, which produces the antibodies, and somatic hypermutation, which may make the affinity more specific. But ultimately, we submit, the big point is this. You're not making a mouse simply so it is immunologically sick. You want the mouse, you're making the mouse to produce the biggest...
Immunologically well, I think you meant.
So that it's not immunologically sick, yes.
It's getting late. You're definitely not making the mouse so it's immunologically sick. You're not making the mouse so it is less immunologically sick than prior art, which I think is what is urged on you as the invention. You want the mouse to produce the biggest variety of antibodies possible. And in order to do that, they have to bind to as many antigens as possible. That's all about combinatorial diversity. The evidence was clear from all the witnesses, accepted by both the courts below, that that was the case. At the priority date, and indeed now, everybody wants as many Vs as possible and would certainly have expected to be able to do this, having read the patent. An extraordinary thing about this case is that the goal of performing across the claim and at the highest level of the claim is actually set by and claimed by the patentee in the body of his description. Not only something that the skilled person would want to do, it's not something that's been made up hypothetically, ex post facto, like some of the other cases we see, like Nabisco, where they're talking about not being able to get some fungus that happens to be barred from access in a particular depository, or future plasmids that we don't even know about. This case is one where the scope of the claim matters fundamentally to what the skilled person wants to do with the mice and what the patentee has taught him he ought to be able to do with his mice. And that's why Regeneron made the claim in the body of the description. Indeed, while the work was done by both parties in this case after the priority date. We submit in conclusion that the approach is simple. If it can't be made, it can't be claimed. You take the claim, you construe it, you establish its scope, and you then ask, given the teaching of the patent, armed only with the common general knowledge, the skilled person could perform it substantially across its scope. The Court of Appeal did the job of construction, they did the job of establishing the scope at 127, they reached the answer on the facts that you could only produce a subset, indeed a small subset at one end of the claim, and they should have faced up to the inevitable consequence of this, that the claim was therefore invalid. My lords, my lady, subject to that reference, which is MS 1257 in Lundbeck's and Generics, paragraph 41. I will briefly read it. What the judge has done is make the requirements for sufficiency differ according to the nature of the inventive step. In my opinion, there's nothing in 72(1)(c) which connects the requirements of sufficiency to the inventive step. What needs to be disclosed sufficiently to be enabled it to be performed is the invention as defined in the claim. That remains the same, whatever may have been the inventive step. We submit Mr. Speck's submissions on this entirely wrong. My lords, my lady, I've overrun slightly and I apologise.
Well, thank you, Mr. Purvis. We're very grateful to all counsel for very clear and helpful submissions, and we're also grateful to those behind them for all the work that's gone into preparation of the parties' cases. It's a fascinating case. We've enjoyed listening to it, and we're now going to have to take quite a lot of time to consider all that's been put before us. We'll let you have our judgment as soon as we can.